Good morning. This is the math department at Amjad High School for grade 11. This is the first video on probability. Let's start with an activity. A first six-sided die is rolled. Here the experiment is rolling a die. In each probability situation, you have to understand what the experiment is. What is the set of all possible outcomes? If you roll a fair die, the possible outcomes are 1, 2, 3, 4, 5, or 6. So this is the set of all possible outcomes. This is called the universe or the sample space of the experiment. So it consists of all possible outcomes of the experiment. Find the probability of getting an odd number. The odd numbers in this sample space are 1, 3, or 5. So A is called an event. It's a collection of outcomes. The probability of any event is the number of favorable cases of A over the total number of cases. So in this case, you will have 3 over 6, and that's half or 50%. What's the probability of getting the number 3? So there is only one possible outcome which is accepted, and that's 3. And consequently, the probability of B will be 1 over 6. What's remarkable about B? B is just an event, but it is an elementary event since it has only one accepted outcome. For example, A here is not an elementary event because it has 3 accepted outcomes. Find the probability of getting a number which is less than 8. If you roll a die, all the outcomes will be less than 8, and consequently all the outcomes are accepted. So the probability of C will be 6 over 6, which is 1, which is 100%. This means that C will occur for sure. What's remarkable about C? C is called a certain event. So an event is said to be certain if it will for sure occur, and the probability will be 1 or 100%. What's the probability of getting the number 7? Can you get the number 7 if you roll a six-sided die? D is the empty set. There are no accepted outcomes, and consequently the probability of D will be 0. D is called an impossible event, denoted by phi, since it has no outcomes. It's an empty set, and the probability of an impossible event is 0. What's the probability of E getting a number less than 5? Here are the accepted outcomes, 1, 2, 3, or 4. And the probability of E will be 4 over 6, and that's 2 over 3. What's the probability of getting a multiple of 2 or an even number? The multiple of 2 or the multiples of 2 are 2, 4, and 6. And consequently, the probability of F is a 3 over 6 half. Now, what's the probability of getting a number less than 5 and at the same time being a multiple of 2? Actually, when we talk about conjunction of two events and making them one event with the word and, this is the intersection between the two events E and F. We deal with events exactly as we deal with sets. And you've studied intersection and union or whatever last year, and this is denoted by E intersection F. So it's the event E and F that consists of all common outcomes, the outcomes that satisfy both E and F and at the same time. So the two events here must occur simultaneously at the same time. The outcomes that satisfy both E and F at the same time are 2 and 4. And consequently, the probability of G is 2 over 6, which is 1 over 3. As we said, events can be represented the same way we represent sets. And here, the common region where the two sets overlap, the shaded region, is the intersection of the two events. Now, what's the probability of getting a number greater than 4? That's 5 and 6, and the probability of M will be 2 over 6, 1/3. N, getting a divisor of 4. What are the divisors of 4 which are in the set of the sample space? These are 1, 2, and 4. And the probability of N will be 3 over 6 half. Now, what's the probability of getting a number greater than 4 and a divisor of 4? So there are no outcomes that satisfy both at the same time. So H is nothing but the empty set, and consequently the probability of H will be 0. Here, if two events M and N have their intersection empty, this means that the two events cannot occur at the same time. We say that these two events are incompatible or mutually exclusive or disjoint, since their intersection is empty. So two events are incompatible if these two events can never occur at the same time. And this is a Venn diagram that models this situation. The two sets are disjoint. There is no intersection or overlapping between these two events or sets. Now, what's the probability of L getting a number less than 4? These are 1, 2, 3, and the probability of L will be 3 over 6 half. What's the probability of getting a number multiple of 2? 2, 4, 6, and that's half. What's the probability of getting a number less than 4 or a multiple of 2? As you've studied last year, or in set theory represents the union. So it's the union between the two events or the sets L and F, denoted by L union F. You shouldn't interpret or as you use it in the common language. Or has a mathematical meaning here. It is the set that consists of all outcomes that satisfy at least one of the two events L and F. It's the set of all elements found in L or in F. If an element is found in both, then yes, it's also considered in the OR. So the intersection is a part of the union. So if this is L, as you can see here, 1, 2, 3, if this is F, 2, 4, 6, then the union, the set of all elements that satisfy at least one of these two, is 1, 2, 3, 4, and 6. And consequently, probability of K will be 5 over 6. The union is the shaded region, all of L and all of F. As you can see, if you shade all of L and you shade all of F, the region here, the intersection, will be shaded twice. That's why when we talk about the union, you have to be careful. If you consider all of F and all of F, then the region of the intersection is counted twice. That's why you have to subtract it. That's why if we have if L is this set, F is this set, L is this set, F is this set, and L union F is this set. I mean, probability of L is half and the probability of F alone is half, then the union is 5 over 6. If we compare these two, as I said, probability of L, you counted all of L. Probability of F, you counted all of F. But the region of intersection is counted twice. That's why you have to take it out once so that you count it only once. And consequently, if you compare them, you will get these relations. And the most important formula that you need to know by heart, and this formula is always true. Probability of the union, L union F, is probability of L plus probability of F minus probability of the intersection. This is true for any two events, L and F, whether they are incompatible or whatever. Now, what's the probability of getting the number 4? For W is an elementary event, and the probability of W is 1 over 6. What's the probability of getting a number different from 4? All the numbers are accepted except 4. R is related to W. R is said to be the complement of the event W. Like if it's raining, then the complement will be not raining, everything else. W bar consists of all non-favorable outcomes to the event W. So if W is 4, then R will be everything except 4. 1, 2, 3, 5, 6. And consequently, the probability of R is 5/6. So if W is here, the white circle, W bar will be everything which is outside W. We have W is 4, R is 1, 2, 3, 5, and 6. Probability of W is 1/6, and probability of R is 5/6. So we say that the event R is the complement of the event W because it's everything except what's there in W. In other words, we say that R is nothing but the complement of W, which means W bar. What about R intersection W? Is there any intersection between these two sets? For sure not. What about the union of these two sets? It will be the sample space because R consists of everything which is outside W. So we're talking about W and everything which is outside W, and this will be the sample space. Now, probability of R plus probability of W is 1. And this is always the case whenever the two events are complementary. So the probability of one of them will be 1 minus probability of the other. So if there is 10% chance to rain tomorrow, then there will be 90% chance to be not raining tomorrow. So in general, an event and its complement have no intersection. Their union is everything. The sum of the probabilities is 1, or the probability of one of them is 1 minus the other. Properties. In general, if A and B are two events of a sample space omega of a certain experiment, then these properties are always true. Then the probability of A union B is probability of A plus probability of B minus probability of the intersection. You need to know these formulas by heart. A and B are said to be incompatible or mutually exclusive if and only if probability of A intersection B is 0. Two events are said to be complementary if not only the probability of their intersection is 0, but also the probability of the union is 1. So if two events are complementary, yes, they are mutually exclusive because the probability for their intersection is 0. But the word that describes the situation more precisely is complementary because the probability of the intersection is 0 and the probability of the union is 1. Here you need to know these formulas, which I think you know from last year. These are called De Morgan's theorem because, as you can see, sets and probability are related, and sometimes we need some formulas to help us solving some exercises. What I'm saying here is that the complement of A union B is A bar intersection B bar. In words, we say that the complement of the union is the intersection of the complements. Also, the complement of the intersection is the union of the complements. We need these formulas to be used in some problems. Application 1, let omega be a sample space. A and B are two events with probability of A 0.2, probability of B 0.4, and probability of A intersection B 0.1. Calculate probability of A bar and calculate probability of A union B. As we said, the probability of A bar, which means not A, that's nothing but 1 minus probability of A, and that's 1 minus 0.2, 0.8. Now, what is the probability of A union B? Using the formula, it's probability of A plus probability of B minus probability of the intersection. Plugging in the values, you will get 0.5. Application 2, let's see at DB two incompatible events of omega such that probability of C bar is 0.8 and the probability of D bar is 0.6. Calculate probability of C union D. As usual, we say that probability of C is 1 minus probability of C bar, and that's 0.2. Probability of D is 1 minus probability of D bar, and this will be 0.3. Now, to find the probability of C union D, you apply the rule. Probability of C plus probability of D minus probability of C intersection D. But what's remarkable here about C intersection D is that that's empty set and probability of C intersection D is 0 because we are given that the events are incompatible. Plugging in the values, you will get 0.5. Application now. I'm going to give you the experiment. You have to think of the sample space. Don't forget the sample space is the set of all possible outcomes. What's the sample space in case you roll a fair four-sided die? It will be 1, 2, 3, 4. What are the outcomes if you are flipping a fair coin? As you know, when you flip a coin, you will get either a head or a tail. That's why if I ask you what's the probability of getting a head, this will be 1 over 2. What if the experiment is flipping a fair coin twice? Here you have to be careful about the events, about the outcomes. An outcome is a couple, is a pair, because you are flipping a fair coin twice. For example, if you tell me head alone is not an outcome. Head is a possible outcome. So each outcome is a pair. Head tail is an outcome. Tail head is another outcome, and tail is another outcome. So if I ask you, for example, you are flipping a fair coin twice, what's the probability of getting 2 tails? So it will be this outcome will be the only TT will be the only accepted outcome, and the probability will be 1 over 4. Application 3. The students of a secondary class are distributed as shown in the following table. We're talking about gender, Lebanese, American, French. We're talking about boys and girls. Sorry, we're talking about nationality, I mean Lebanese, Americans, French, and we are talking about gender, boys and girls. Complete the following table. It's easy here. If the total number of Lebanese is 13, and you have 5 Lebanese, so you will be left with 7 Lebanese girls. If the Americans are 2 boys and 7 girls, then the total will be 9 Americans. If the French boys are 3 and you have a total girls of 20 and you know these two to be 7 and 7, then you will be left with, here you have 8, sorry, 8 and 7, which is 15, so you will need a 5. So this is the table completed. One student is chosen at random. So the experiment here is choosing one name out of the 30 names. Calculate the probability of each of the following events. The chosen student is Italian. H is an impossible event. According to the table, there are no Italians here. And the probability of H will be 0. This is the impossible event. F, what's the probability that the chosen student is French? How many accepted students are there? 8. So the probability to get a French student will be 8 out of 30, which is 4 over 15. What's the probability of B, getting a boy? Actually, there are 10 boys, as you can see here. There are 10 boys, so this will be 10 over 30, which is 1/3. What's the probability of the event E, the chosen student is not American? By the way, to calculate this event, there are 2 methods. Either you find the probability of being American, and that's clearly 9 over 30, then you will do 1 minus that, because this is the complementary event of the event American. Or you can count from the table all the students who are not American. So you count all the Lebanese plus all the French. So probability of E is a probability of being not American, and these are 21 students. Or you can do it probability of not American, 1 minus probability of being American, 1 minus 9 over 30, and that's 7 over 10. Now, what's the probability that the chosen student is a Lebanese girl? Actually, this is a conjunction. It's an intersection. You want the student to be Lebanese, and at the same time, you want her to be a girl. So if you look here to the girls, at the girls and at the Lebanese, there are 8 students satisfying both conditions. And that's 8 over 30, which is 4 over 15. Now, what's the probability that the chosen student is a girl or Lebanese? I advise wherever you see the expression or, I advise you use formula because some students will interpret the or in an incorrect way. Actually, we can count if you know how to count. Like I count all the girls and I count all the Lebanese, but I have to be careful not to count it twice because here these 8 could be counted when you're counting the Lebanese and when you're counting the girls. So you may count these twice. That's why you have to count them once. Or you can do it with a formula. It's probability of Lebanese plus probability of girls minus probability of Lebanese girls. Now you replace because we have all of these and the answer will be 5/6. Application 4. In a bag there are 12 identical tokens numbered from 1 to 12. Numbered 1 through 12. One token is drawn at random. Calculate the probability of the following events. The probability of getting the number 2, that's 1/12. Probability of getting the number 7, that's 1/12. Probability of getting an odd number. The odd numbers are 1, 3, 5, 7, 9, and 11. These are 6 out of 12, so half. What's the probability of getting a prime number? You know what a prime number is? It's the number divided only by 1 and by itself. So the prime numbers here are 2, 3, 5, 7, and 11. And that's 5/12. What's the probability of getting a multiple of 3? The multiples of 3 are 3, 6, 9, 12. These are 4 options out of 12 possible. So it's 1/3. What's the probability of getting a divisor of 12? The divisors of 12 are 1, 2, 3, 4, 6, and 12. So the answer is 6/12, half. What's the probability of getting an even number and a multiple of 3? This means intersection. The numbers that satisfy both are 6 and 12, and the probability is 2/12. What's the probability of getting an odd number or a multiple of 3? So it's the probability of odd union 3. As I said, I advise you use formula whenever you have union. So this is the probability of odd plus probability of multiple of 3 minus probability of odd and being a multiple of 3. That's 6/4 plus 4/12. Now, the odd numbers, which are also multiples of 3, are 3 and 9, so minus the common set 2/12. Finally, the answer will be 2/12. Thank you for this session.